but my name's Sean Fury. I'm the director of the Rural Water Supply Network Secretariat based at Scout Foundation in Switzerland. And it's my real pleasure today to introduce many fantastic panelists and speakers. And to help me with that is Jennifer de France from the World Health Organization in Geneva. So, Jennifer, please, over to you.
Thanks very much, Sean. And firstly, thank you to Kirsten for inviting me to be part of this webinar. I'm really excited to be here as this issue is really important to me and WHO more broadly. So firstly, why are we interested in this at WHO? So we know water, we all know water is critical for health, for our livelihoods, other socioeconomic benefits. We also know that rural water supply, it's critical to provide more support. The data is very clear on that, with 2.2 billion people still not having access to safely managed drinking water services, where a larger proportion of people do not have that access in rural areas. So there's significant inequalities in delivering safe, sustainable rural water supply. And so there is a need to provide much more support. Recognizing this, WHO earlier this year published guidelines for small water supplies, where most of it is in rural areas, as well as supporting practical tools, the sanitary inspection tools. Now, these guidelines recognize the importance of corrosion, and so it's great that this workshop is focusing more on this specific issue, where we know corrosion affects delivery of safe water, impacting the operations, delivery has financial implications, etc. So it's great that we'll be hearing more about experiences with addressing the challenges and some practical guidance to support prevention of corrosion. So we'll hear more about that in a bit. So with that, I just want to say it's great to see all of you joining from all parts of the world. I saw people from Europe, Africa, Latin America, Australia, so all over the world. So good morning, good afternoon, good evening to you all. And with that, I hope you will enjoy this webinar, and I'm going to hand it back over to Sean to provide an overview.
Great, thank you very much. So today we have a wide range of panelists and speakers from Zambia, from Uganda, and from the World Bank, and from WaterAid, and from government. So we'll be hearing all about those as we go forwards. But let's just turn now to today's agenda. So we've done the housekeeping. We've had the opening by Jennifer. The presenters today, I'm going to give a short presentation, very short. Then we'll hand over for three presentations that will take us through some of the issues around corrosion. And then we will go to the panel discussion, which we hope will be very lively and engaging. And then closing remarks will be with Jennifer, just to round us off. So before we get going, let's just give a quick overview of what the Stop the Rot initiative is. This is one of our flagship programs that's been going since 2021, kindly supported by the Waterloo Foundation in the UK. And it really is focused on catalyzing action around eliminating this problem of hand pump corrosion that, as you will hear, affects millions of people, not just in sub-Saharan Africa, but particularly in sub-Saharan Africa, and is one of those problems that's been known around for decades and should be solvable. And I think together, one of the things we really want to get across is that this is a widespread problem that together we can fix with a combination of partnerships between research, policy, standards, good quality implementation, and a range of just all the bits of the puzzle coming together. So that's what we're doing in this Stop the Rot program that is currently been activating new research to fill in the knowledge gaps, that's been developing new guidelines that you'll hear a bit more about today, and also catalyzing in-country action, which you'll also hear about. So that's enough about that. Just like to thank all the project partners that have been really part of this so far, particularly the Waterloo Foundation and also Kirsten down at Ask for Water for really leading and spearheading this initiative for RWSN, and for all the people, the wide cast of wonderful people that have been part of the action group and really making a difference. So let us move to the first presentation. Thank you.
Good morning, good afternoon, and good evening. It's very good to be here today, and I'd like to present you with the newly launched World Bank Knowledge Note, which builds on the work by the Rural Water Supply Network. This note advocates for the establishment, monitoring, and enforcement of regulations to prevent the rapid corrosion of hand pumps. In sub-Saharan Africa, approximately 200 million people rely on hand pumps as their primary source of drinking water, with an estimated 700,000 hand pumps in use. Although other technologies are gaining popularity, hand pumps are expected to remain considerably important in the region for decades, especially in remote or sparsely populated areas. Unfortunately, many hand pump services face performance issues or premature failure due to technical or installation defects in the borehole or in the pump. Operational and maintenance weaknesses and financial constraints can also lead to performance problems. Rapid corrosion of hand pumps has been known about for decades, but it continues to occur despite the existence of technical solutions. Given the continued and widespread impact of this issue, it's imperative that decisive action is taken. And these regulations, which we're going to talk about on the next slide, could be applied at national, state or regional level, or with recommendations to use a pH threshold, which we recommend is below 6.5 as an indicator of corrosion risk. Other risk factors, including salinity, chloride and sulfate, can be added once they're better defined. So the Knowledge Note proposes 3 articles that are introduced into national regulations or other appropriate means. The first is to prohibit the use of galvanised iron riser pipes and rods, either through the country, within particular local authorities, or particularly in specific cases with a pH of less than 6.5. Each country will need to determine what's most appropriate for the particular context, and that's something that we may want to discuss later. Secondly, it calls for countries to stipulate the way that pH is measured and reported. And thirdly, it calls for the respective authority to monitor and document the performance of alternative materials. That's alternatives to galvanised iron, also known as GI. So what's the justification for this knowledge note? Well, all metallic components that are submerged in or that move in and out of water will eventually corrode. But if components of inappropriate material are installed in aggressive groundwater, they'll corrode very rapidly, and you can see some examples here in the photographs. So rapid corrosion of submerged steel and GI, galvanised iron, hand pump components is one of several reasons for a swift technical decline of infrastructure, reducing its lifespan and affecting its functionality. What happens is sometimes components that should last for 8 to 10 years need to be replaced within a few months or a couple of years. Galvanised iron hand pump riser pipes or rods in low pH water can corrode very rapidly, as can materials with inadequate galvanising quality and low quality stainless steel as well. And in fact, these materials can also corrode, these low quality materials can also corrode in water that's not even very aggressive. Rapid hand pump corrosion results in high levels of iron in the water, and that often leads to users rejecting that water because of the taste and the colour. And these issues, alongside premature failure, can basically result in users no longer having access to a safe drinking water supply. Then reduced pump lifestyle increases the operational costs to keep services working. So there are also economic implications. Frequent replacement of rapidly corroding components is costly, and it also drains limited human resources. And corrosion can also allow drinking water to become contaminated by lead and other heavy metals of concern. Detrimental impacts may occur before clear signs of corrosion are actually observed. The phenomenon of hand pump corrosion has been recognised for decades, and yet inappropriate hand pump materials continue. A recent RWSN study found that communities in at least 20 countries in sub-Saharan Africa face the problem of rapidly corroding hand pumps. Simple tests do exist to determine whether the iron that you observe in the water is coming from the aquifer naturally, or it's caused by the corrosion of the pump. They involve monitoring the change of water colour during pumping. And basically, external support agencies, implementing organisations, contractors, funders, all require incentives to consistently install hand pumps of good quality. Basically, if this issue isn't properly addressed, rapid corrosion will continue to undermine the achievements of the Sustainable Development Goal Target 6.1 and undermine the achievement of national targets. The occurrence of rapid corrosion can be prevented or minimised with due attention to the appropriate material selection and its installation. Preventing rapid corrosion of hand pumps involves avoiding the use of GI, galvanised iron rising pipes, or low quality stainless steel in wells where water has low pH levels. A threshold of 6.5 pH is generally appropriate as a corrosion risk indicator, but other aspects of the water chemistry, such as high levels of salinity, chloride and sulphate, are also risk factors. Alternatives to GI include high-grade stainless steel or lead-free UPVC with stainless steel couplers. Notably, the appropriate combination of materials is required to ensure sufficient strength at depth and to avoid galvanic corrosion. Galvanic corrosion is something that happens when dissimilar metals are in contact with each other and in solution. And there are also other issues around proper handling of alternative materials. Special attention needs to be paid to the transportation, storage, installation and maintenance of stainless steel and PVC pipes. So what are the considerations for effective regulation? Well, the first, and you can see this in detail on the regulatory note, is to conduct a regulatory impact assessment. Secondly, when developing any regulations, stakeholder consultation is really important, really hearing their perspectives on financial implications, effects on ongoing contracts. That's important. Also, monitoring and enforcement mechanisms are important to be clarified. How is this going to be checked? How are these regulations going to be enforced? National standards organisations should be involved. And last but not least, it's important to keep communicating the changes, the new regulations clearly, widely and continuously to make sure that everybody knows about it. So what are the considerations for implementation? Well, consider water quality in monitoring. Replace rapidly corroding components with alternative materials, so components that have already been installed. Map areas with aquifer properties that can trigger rapid corrosion. Ensure in-country availability of alternative materials. Ensure that's there before regulations come into effect. and develop material certification mechanisms. And last but not least, ensure that implementers incorporate quality control procedures. Just to explain as I close that this knowledge note was prepared thanks to funding from the World Bank Group Global Water Practice in support to the Rural Water Supply Network. It was developed through literature review, online interviews, and particularly in-country lessons from Uganda and also from Zambia. 17 specialists provided inputs and reviews in order to finalise the document, and I just want to extend a huge thank to all of them. Thank you for listening.
Great presentation, thank you. And I think you might have realized that's a recorded presentation, but great, Kirsten's here and she can answer any questions later in the Q&A. It's great that Kirsten was able to present about this note, recognizing that she has so much experience in this area and was the lead author of this technical note. So you saw in the chat that a link has been provided to access this note. So I encourage all of you to read it. I think it provides really useful guidance. So now we're going to hear from Javan Nkosi.
Good morning, good afternoon, and good evening. My name is Javan Nkosi in Lusaka, Zambia. I'll present to you the history of rapid hand pump corrosion problems in Zambia and the potential next steps. This report was presented last year at the annual Zambia Water Forum Exhibition Zawafe Conference. I would like to begin my presentation by giving a context to my report. I start by posing a question. How long will the problem of rapid corrosion of hand pumps be known in Zambia? Many water professionals in Zambia do not know the answer. In 2020, I requested Rural Water Supply Network to peer review my report on the effectiveness of SOMAP model to sustain rural water supply in Zambia. One reviewer expressed surprise on the problem of rust in Zambia, in borehole water in Zambia. Yet this is a major problem in Zambia. He wrote, the problem of rust was well known more than 30 years ago, and a solution was known too. The questions I have from this are: 1. Where is this information documented? 2. What is the extent of corrosion, corrosive or acidic water in Zambia? 3. What has been done to address this problem to date? It is to these 3 questions that I address myself to in this presentation in that order. The documented evidence about the problem of rapid hand pump corrosion was first documented in the project reports of the Central Province Rural Water Supply Project of 1985 to 1996. The project installed 564 hand pumps with stainless steel riser pipes, rods, and pumps because of the corrosive groundwater. The second report is documented information is the 27th WEDIC conference, which was held in Lusaka from the 20th to the 24th August 2001 in Lusaka. In the paper India Mark II Maintenance Systems by Frank Pitcher, he presented two projects, the Eastern Province Rural Water Supply Project and Central Province Rural Water Supply Project of 1985-1996. The Central Province Rural Water Supply Project used India Mark II hand pumps with stainless steel riser rods and riser pipe. The third report is the Wedi consultants Harvey and Skinner. This is in the study of sustainable hand pump projects in Africa. The Wedi consultants visited Zambia in April and May 2002. The findings include, say, this statement. In Central Province, due to corrosion, galvanized iron riser pipes were changed to stainless steel riser pipe. The fourth paper was from the 28th Wedi conference that was held in Calcutta in India in November 2002. A paper by Harvey, Skinner, and Reed entitled Sustaining Hand Pumps in Africa, Lessons from Zambia and Ghana. The common problem that was stated in both Ghana and Zambia is aggressive water that resulted in rapid hand pump corrosion. And the solution was the modifications to the India Mark II in both Ghana and Zambia. In Zambia, the modification of India Mark II is a standardized pump in one province of Central Province. From the above four documents, the project files and the Wedi papers and report puts it that the issue of rapid corrosion was well known in 1985, and the solution was the use of stainless steel pipe or UPVC riser pipes. The second question is on the geographical extent of aggressive water in Zambia. The response is taken from the work of the Soil Survey Unit of Mount Makuru Agricultural State Station here in Zambia under the Ministry of Agriculture. The survey unit mapped soils of the whole country. There is a report, the Soil Map of Zambia 1987 second edition. The soil survey has delineated the agroecological zone into three regions, Region 1, 2, and 3, with the following characteristics. Region 1 has 800 mm rainfall per annum, and the soils are slightly acidic, covering 12% of Zambia's landmass. Region 2 experiences 800 to 1,000 mm of rainfall per annum, with the soils which are acidic. This covers 42% of Zambia's landmass. Region 3 experiences 1,000 to 1,500 rainfall per annum. The soils are extreme acidic. This covers 46% of Zambia's landmass. The rainwater, which percolates through the soils to the groundwater, picks the acidity from the soils. This gives the recorded level of acidity in the groundwater. This results in groundwater to being acidic to extreme acidic with pH range of 5.4 down to 3.2. The acidity to acidic condition extends to 88% of Zambia's landmass. This slide shows the agroecological zones and the soil acidic maps of Zambia. The three regions are well delineated, spread out, as you can see. The second map shows the soil acidic map. The soil acidic map is delineated according to the low level of pH, low level of acidity. That's the pH levels. The third question is on the history of efforts in Zambia in relation to rapid hand pump corrosion. I've picked 8 studies and projects that have been conducted since 1985 to date, that have been conducted to address rapid corrosion in Zambia. 1. The Central Province Rural Water Supply of 1985 to 96. 2. The Rural Water Supply in Northwestern Province. 3. The Groundwater Development Project in Luapula Province. 4. The SOMAP 3 Pipe Replacement Study by JICA. 5. The Water Sector Program Support. 6. The UNICEF Pipe Replacement Study in Luapula Province. 7. The UNICEF Borehole Drilling and Rehabilitation Program. And 8. The Scaling Up of Nutrition on Technical Assistance SANTI-A project. What is the conclusion? The conclusion is 1. Aggressive or acidic water is found in 2 regions, Region 2 and 3 of Zambia's agroecological zones, 88% of Zambia's landmass. 2. Rapid hand pump corrosion in Zambia has been known and documented since the 1980s. 3. Efforts to address the rapid hand pump corrosion in Zambia through various studies, but the problem still persists, including new installations. 4. We implore the government, cooperating partners to address the problem of rapid hand pump corrosion. The potential next steps by government, international donor communities, and the universities are summarized in the following. 1. Need to revise the national water policy to include aggressive groundwater in community boreholes. 2. Restrict types of hand pumps to certain regions. 3. Enact statutory instrument on aggressive groundwater in community boreholes. 4. Provide incentives to private sector for provision of corrosion-resistant pipes and rods. 5. Regulation of quality of hand pumps by Zambia Bureau of Standards. 6. Standardize hand pumps used in Zambia. 7. Topics for study. 1. Replacement of galvanized iron pipes. Research studies on naturally occurring iron in groundwater and surface water. 3. Research studies in saline water in southern and western provinces. With these few remarks, I thank you for listening. I beg to move. Thank you.
Thank you very much, Jovan, for that informative presentation about the history of the problem in Zambia with all the research that's been undertaken and highlighting proposed next steps, which highlight different actions to take at different levels, from policy regulations to working with implementers. So I'm pleased now to introduce Annie Kalusa to share some reflections. So Annie is from Empowered Communities.
Good afternoon and good evening.
Okay, I'll try again. So Annie is from Empowered Communities Helping Others, or ECHO, in Zambia. It's an NGO that focuses on improving the well-being of vulnerable rural communities. And her area of focus is on climate-resilient water, sanitation, and hygiene. She's also currently developing her thesis on rural agriculture practices and mechanisms for water resource management. So very, very busy. So I'm pleased to ask you a question, Annie, and it'd be great if you could turn your camera on if you have ability. So the question is, I understand that with working with ECHO, you've done a lot of work to address this problem of rapid corrosion of hand pumps. And so could you share some of the actions that you've taken to address this problem? Over to you, Annie.
Thank you, Jennifer, and everyone. My name is Annie Kalusa Kapambwe as Jennifer's put it. Speaking to you from a local NGO in Zambia called ECHO, an acronym for Empowered Communities Helping Others. We are in the 5th year of implementing the hand pump rehabilitations, and we have rehabilitated a total of 1,343 hand pumps. And I'll be quick to mention here that when we were beginning our rehabilitation interventions, we did not have in our mind to switch to UPVC. We planned to carry on with galvanized pipes. However, our first experience during technical assessment, which requires us to check all the components of the hand pump and examine all the pipes and check the functionality and the entire hardware mechanism of the hand pump, we began to see that most of the pipes that we were taking out from the hand pumps were corroded. And we would hear people from the communities coming to complain to us. And mostly they would say, this hand pump was only drilled 6 months ago, and these pipes are new, but they're already turning brown. And also that one, we took keen interest in taking history of the hand pump from the communities who are reliable and were custodians of information maybe about that particular hand pump. So they would come forward, yes, to volunteer information and complain about how the water from a newly drilled borehole has changed. The taste would be that of rust, and also the color after a few minutes of fetching would change. And in many cases would find pipes corroded to the extent of looking like a thread. So we came back to sit as ECHO to find a solution, whether to carry on with the GI pipes or to find other best options. So that is how we resorted to switching from galvanized pipes to UPVC. And within the technical assessment, we also do what we call initial water quality as part of technical assessment. After you flush, after you pump test, we do water quality sampling. So we found that for almost all the hand pumps that had galvanized pipes, the pH was very low. And we wanted to find out, of course, there's no scientific study to what I'm sharing. These are just our own observations and experiences. But these tests were done in a reliable laboratory back home in Zambia, of course, recommended by the Ministry of Water. So as the pH results were low, that also for us became an highlight, and the need for us to be cautious with the choice of materials. So again, the low pH led us to resorting to using UPVC. And of course, apart from that, we would gather information from the villagers who would complain if there is any other material which was better than the GI pipes. So that's how we resorted to using the UPVC. And our experiences after installing these hand pumps with UPVC, we found that communities observed that the color of the water stopped turning to brown. And this is information that we keep gathering, especially even during our full follow-up activities. We also have recorded reduced ion results in the water, and we have also gotten feedback from the people that there's no odor anymore in the water, and also that there is no rust taste in the water, and the water doesn't change the color to brown. And so we feel that this is a solution for us to addressing the hand pump problems. Of course, we have many other measures that we have put in place. Others are what we are calling system strengthening, where we have identified through the local authority, the area pump minders, who come in to offer the operation and maintenance services on hand pumps. And these two are the custodian of information on the characteristics of the hand pump. So you find that for any changes happening at a particular hand pump, we get first-hand information from the area pump minders and the community in general. And we also have evidence now from the regular water quality monitoring after the initial rehabilitations, and people have started utilizing the hand pumps. So every year we go back to all the 1,344 that we have rehabilitated to conduct what we call water quality monitoring follow-ups, to check, because of what we experienced at the beginning of the intervention. We double check with what is happening now after switching from galvanized to UPVC pipes. And the evidence is that for majority of our hand pumps that we have rehabilitated and switched with UPVC pipes, we no longer have low pH. And for the ones that are still showing low pH, we are trying to get guidance from the Ministry of Water in case there's been any research and what could be the reason. And this is coming from the Western Zambia. We would like to recommend for further research, because in some cases, some of the hand pumps with the UPVC still give us low pH. And we would like to recommend, particularly even through this forum, scientific study of what could be the causes of the low pH in the water. So this, in brief, has been our experience with the GI pipes and the switch to UPVC pipes.
Thank you, Annie, for that comprehensive response. I appreciated you mentioning just about the need to get information from communities for the initial problem. Then once you change to UPVC, seeking their feedback as well as the local operators. So, this is highlighted in that technical note that Kirsten talked about, needing to get feedback from stakeholders, and you clearly showed the how that's been done with ECHO. So I'm sure people have questions for you, as well as the first presenter from Zambia and Japan. Just to say that, again, there is a Q&A session, so please post any questions that you may have for Annie and Japan to discuss during the Q&A. So Annie, you highlighted the importance of role of government. And so I'm pleased that our next presenter is someone from government, from the Ministry of Water and Environment in Uganda. This is going to be Mutibwa Robert. He's going to present the experiences and lessons that have been learned in preventing the rapid hand pump corrosion problem in Uganda. So let's hear from the video from Mutibwa Robert.
Prevention of rapid hand pump corrosion in Uganda. My name is Robert Mutibwa with the Ministry of Water and Environment. Let's take a look into the Ugandan context on the use of hand pumps. We have 67% of the rural population covered by safe water supply. 84% of the rural water systems are functioning at the time of visit. 80% of villages have a safe water source, and the existing stock of water supply, point water supply sources has got 63,000 hand pumps, of which the ministry also estimates that the rural population, 44% are covered by boreholes and 23% covered by shallow wells. The analysis also suggests that nationally, 43% of the population rely on hand pumps as their source of water supply. In Uganda has been done, and the question here is perhaps why undertake a study and initiative in Uganda? Simply stated, Uganda has taken a systematic approach to address the issue of rapid hand pump corrosion by issuing a directive in which everybody who is involved in the water supply dealing with the hand pump technology must adhere to. So in the year 2016, the use of galvanized iron was eliminated within the country, and this gave the threshold onto which Stop the Rot initiative has been looking into. So over the years, what have we learned in terms of the suspension? In the early years of the suspension, this information was disseminated to all sector players, people that are involved in the drilling of boreholes. These are local governments, we have the NGO fraternity, we have the UN agencies, and then the government asked every key player to come and have a meeting. So we had a long discussion for a couple of days, and this actually also included the suppliers of the pumps and the contractors that do the drilling. And the initial challenge, of course, that was raised then was how are we going to determine the proper quality of the steel, stainless steel that we are migrating to. But of course, this has been a process which took us about 3 to 4 years. Over the time, we have had players accepting to work within this directive. Now, why issue such a directive? And the photograph on the right of your screen clearly shows why. I mean, if you have this as a point water source with this color of the water, it's not worth being considered as a safe water source. So this directive was coming in to address such concerns, as you can see. Now, through time, it is very, very important that finding what works is not an easy thing. I can say it's almost about 8 years since the directive was issued, but we're still finding what works as a country. Initially, some organizations took on to the stainless steel and had grade 202 installed, but over time we also found that this is also undergoing the rapid corrosion. Other organizations took onto the plastic pipes with the stainless steel couplings, and these have been very useful and good. But also through the years, we have also realized that some people are resorting to have mixed installations. By mixed installation, we have a borehole which has got both galvanized iron pipes and stainless steel pipes. Now here, the stainless steel pipes are the ones that are being put in the water, while the GI pipes are above the water. I don't know whether this helps, but definitely it's not a solution that we're looking onto. So the ongoing questions about which stainless steel grade is most appropriate, that is now what the country is addressing. And beyond that, how do you quality assure, how do you check the grade of the stainless steel? That's what we are having. So far, we feel that the grade 304 is appropriate, but we have also had cases where other organizations are installing grade 316, which is of course a lot more better. Now, nonetheless, there still exist some stakeholders who are using galvanized pipes as of today, but we also want to understand why are they still insisting on the use of GI as opposed to directive. Now, the key findings over time have been that the directive has been largely appreciated by many sector players. Of course, there are also challenges that the directive has met, in that the time of issuing the directive is 2016, and the directive is referring to standards that are 14 years back. So 2002 standards are being recalled in the directive until 2016. So there are issues there that we need to look into as a country. And of course, there are still quality challenges, including how do you recognize the stainless steel grade, or how do you recognize the inferior products. The photograph on the right is showing you a bit of what the corrosion has been doing, and this is the mix of the GI pipes and the stainless steel. Of course, it comes along with cost implications, but I mean, maybe that's what sector players have to agree and agree to live by as the key standards. To give a bit of the story, we can see that some of the stainless steel pipes that have been installed have got maybe vertical cracks and horizontal cracks, and this could either be due to the quality of the material, or the quality of the installation, or the quality of handling. So all these are issues that we are trying to manage as a country, as we migrate and try to and work towards implementing the directive. Now, there have been also other researches that are looking at how we can improve the existing technology, and yet still be able to manage the costs in certain parts of the country. We have had the installations of PVC, which is connected with galvanized iron. The first phase had 6 boreholes installed, and we as government are monitoring this very closely. They have functioned very well. We are looking at improving a few design improvements, and also increasing the number to 100. We hope we can have the 100 scattered a bit in different parts of the country where the chemistry of the water is quite different, and then we also see how this is going to work out. Perhaps this might be the solution to the outstanding problem of the cost of the stainless steel pipes. Then we are coming up with a few recommendations, some of which are local and some of which appeal to the institutions of academia, those that are involved in the research and development. And then we're also looking at ourselves as a country, learning from our other countries. Locally, we are looking at about 7 recommendations. The migration to stainless steel requires a high cost. I think that the first key recommendation is they need to support the poor and the vulnerable communities. Governments or other NGOs need to come in and support this to be able to have the complete overhaul and change from the GI to the stainless steel community boreholes. We have also seen that in order for the technology, the new pipes that are coming in, the human resource that exists has been very much used to working with the galvanized iron pipes. So therefore, it is necessary that they are trained on how to handle stainless steel pipes. It is also important that we support the quality assurance efforts, so that whatever is found on the shelf is the material of right quality and standards that meets the requirement. So they need to develop a certification mechanism. Now, it goes without saying that awareness creation is very, very important. People need to understand why they have to go to the stainless steel, and why they need to suspend the use of galvanized iron, what are the appropriate alternatives, and what are the simple tests that can be done to tell whether corrosion is from the iron pipes or is from the aquifer, and so many other things that need to be done. But these are still recommendations, and I could say works ongoing. As a country, their experiences we're still learning from. In terms of studies and research, it's important to explore reasons why stakeholders are not adhering to this directive, because some of them still want to use galvanized iron. I also think that a lot of emphasis has been put on the below ground parts, but we also need to look at parts like the pedestal stands, the tank, and maybe the head assemblies, how corrosion is affecting them. This should also look into the studies, the research should also look into what are the maximum appropriate depth of installation that can be used. It's important also that we develop a user feedback for the user communities, and how they can give feedback to us as the policymakers on whether the technologies being put in place are very good and can meet the desired effect. research to demarcate areas where groundwater is aggressive is very, very vital, so that the implementation of the directive can be done piecemeal. Some waters are not as aggressive as others, and so in such places where the water has got a very friendly pH, it is still possible to use galvanized iron and not have corrosion. So I think countries need to take on that. Of course, lastly, I think that we as a country are so much interested in the Stop the Rot initiative, because it's going to link us with other countries, especially I've seen Zambia and Cameroon and how they are doing. We want to learn one from each other so that we can make sure that our works are leading to supporting our rural communities in having access to safe water and sanitation. Thank you so much for listening in. I would like to end here. Have a good day.
Thank you very much, Robert, for that presentation. I think it was really rich and useful for everyone to hear about the long history with suspending GI pipes, but that you're still learning from that and aiming to adapt the regulations, research, and other activities as you gain more experiences. So now we're going to hear from your colleague, also in the Ministry of Water and Environment, Erisa Kiuni, who's a senior water officer. He has more than 20 years of work experience in planning, development, monitoring, and quality assurance of groundwater-related service delivery, and including managing the construction of over 7,000 boreholes. He's also part of the team handling sustainability, operations, and maintenance of rural water facilities in Uganda. So with that experience, it'll be great to get your reflections about the issues. Particularly, what do you see as the priorities for the ministry related to the findings? So Erisa, if you can turn your camera on, that would be great when you respond. Over to you.
Good morning, good afternoon, good evening, everyone. Thank you, Jennifer, for the opportunity. As introduced, my name is, and I work with Robert, the previous presenter. Just to share with everyone the experience of the GI, the rotting of pipes. Robert said it all, that like other countries, we've been experiencing the rotting of pipes. It's a very serious issue in Uganda. Through the study, as indicated, the study points to really regulatory issues, that if we are to stop this rotting of pipes, okay, mainly all the action areas are centered on government. Okay, we need to look at the standards of the pipes that we are installing in our boreholes. We need to, first of all, look at the water. As you know, the chemistry of water varies from country to country. So as Uganda, we are also thinking of carrying out research in the different parts of the country so that we know what quality of pipe is good for which region. So as a starting point, I think that's what we need to do as government. Secondly, we as Uganda, we have a standards body here. As indicated in the report, the standards were developed for pipes, but these seem to be old, so we need to keep on updating standards. We also have a standards committee, which comprises of UNICEF, NGOs, the ministry, the academia, but which has not met actually for close to 15 years. So as a ministry, we need to revive it so that there is a keen follow-up on the standards of the pipes in the country. Now, the experience we've had as a ministry, we banned, like Robert indicated, but still we have pipes being installed down there. And to me, there are like 4 issues. First of all, these hand pumps are located in communities down there, and as a ministry, we are thin on ground. We can't monitor what is being replaced. Robert indicated that in some of the boreholes, you have hand pump mechanics who are not trained. They keep on replacing. When a bore breaks down, for instance, if you have stainless steel, they will come and install bad GI pipes. Then we also have issues of recycling. People remove bad pipes, take them downtown and respray them. And these communities, for them, they don't know how a good or bad pipe looks like. So we need to build capacity. We need to build our monitoring. We need to train hand pump mechanics. We also experienced that much as we banned, we don't control. The communities are saying the GI you are telling us to buy is expensive. It's 3 times more, and that one is out of our control. So those are some of the issues we picked up, and they're like, much as you want to have this blanket ban and stopping the rot, there are lots of other issues down there. Okay, so as government, we need to regulate more. Like I indicated, most of the issues are regulatory and are to do with government. We need to ensure that the pipes on market are very good, because we rely on imports. And personally, I'm of the view that we need to encourage in-country manufacture of pipes. Because some of the countries like Uganda, we have the iron ore. The iron ore is here. We can get the steel. We have farms that are already into steel manufacturing. And actually, we used to have a farm here that used to do the galvanizing. So we need to encourage local manufacturing through a private public partnership, and that's still a role of government. And I believe with those actions we can end the rotting. Because most of the issues we wait for the pipes to come into our borders, and then we start crying. So if we have local manufacture, regulatory, a mix of many things burning, then we will have solved the problem. Thank you so much.
Thank you so much, Arissa. Really appreciated you unpacking the role of government in supporting this issue. Government leadership is key. And so you explaining that more is really, really critical. And just to say, I commend Uganda looking to see about revising the standard, thinking more about taking a risk-based approach where potentially use of GI is okay and should be considered, where the water isn't aggressive. So I think that's really much in line with WHO guidance and is a practical step. So we're going to hear from another colleague from the Ministry of Water and Environment. This is Paul Bisaborawa, and going more or further elaborating about the challenges. So Paul's a senior sociologist with over 18 years of experience on environmental and social safeguards for infrastructure projects. And he has also been involved in the field work and interviews for this study. So it's really interesting perspectives to share. So we'd like to hear from you. What do you think are the biggest challenges for the government in relation to preventing rapid corrosion in Uganda based on your work? So Paul, if you could turn on your camera, and I hand it over to you. I'm not sure, is Paul there? Paul, I see you on here. Hopefully you can connect soon. If not, we can go to the next discussant, then come back to Paul. So we can go to Francois. Francois, maybe you can turn your camera on now. That would be great. Francois Berton is a senior water resource management specialist at the World Bank. And so I need to, with over 30 years of experience in groundwater resource management. And you joined World Bank, I understand, in 2020. So you've been involved in this technical note, I think the lead at World Bank. So it'd be great to hear your perspectives on why you commissioned this knowledge note. And what are your hopes with this publication? Over to you.
Thanks, Jennifer, and hello everyone. Well, my hopes. Okay, when discussing government investment in the water sector, let's say that it's crucial to acknowledge the challenge of setting priorities. We know that exploration and knowledge development in this field are obviously essential for long-term management of the water resource. However, governments often face the pressing need to rapidly provide safe water to population without access. While exploration and knowledge contribute to scientific understanding of sound resource management, they may not be as immediately urgent as addressing the immediate water needs for underserved communities. In discussing handpump corrosion, we find ourselves at a unique juncture where we can swiftly translate knowledge into action. This presents a unique opportunity that the World Bank cannot afford to overlook. Leveraging our influence, we can empower countries to convert the understanding of the cause of handpump corrosion and their knowledge of groundwater quality into tangible actions. Specifically, these entails advocating for regulatory instruments to ensure that every installation of handpumps for public water supply is a durable investment. No matter who is installing the pump, government, NGOs, private, if the pump is for public water supply, this regulatory instrument shall apply to prevent missed opportunities, and missed opportunities is really the key word there. It's important to underscore the consequences of installing the wrong handpump. Not only does it result in increased maintenance cost and operational complexity, but a corroded handpump often ends up being abandoned, as Annie mentioned a few minutes ago. This not only deprives communities of access to clean water, but also prolongs the period until an operational pump can be installed. It's our hope at the World Bank that the knowledge note we are discussing today will also educate all stakeholders about the risk associated with improper hand pump selection, thereby helping to prevent these missed opportunities and ensure more effective water access solution for target population. Thank you, Jennifer. Thank you all.
Thank you so much, Francois. And let me extend my congratulations on this guidance note. I think it's really useful, and I think highlighting the role of regulation. So not just highlighting the challenges, but how regulations can help, and advising on that issue practically with considerations for oversight of regulations, I think is really useful. So thank you again. Okay, so we're gonna see if we can get Paul back. Paul, are you able to turn on your camera and speak, elaborating on what you see as some of the challenges and how they could be overcome? So I'll just wait a little bit just to see if you can join. Otherwise, we'll move on to our last discussant.
Hello.
Fantastic. Paul, over to you.
Yes, please. Thank you so much. Unfortunately, today I don't have webcam, so you will not be able to see my face. However, about my concerns, like my colleagues have already reiterated, it is mainly to do with a more fragmented arrangement for regulation and implementation of water supply in the country. Initially, borehole drilling and hand pumps were a responsibility of the Ministry of Water and Environment. So the Water and Environment Ministry would be responsible for importation of all materials, installation, and replacement of these materials. I'd want to bring in the other players like UNBS at quality assurance level, but the specifications will be a design agreed by and upon by the Ministry of Water and Environment, and that is no longer the case. So because the responsibility of standards is with UNBS, the responsibility of installation is with the Ministry of Water and the local governments, and the responsibility of importation is with the private sector. And so the story kind of breaks along the way. And therefore, some of these incidents is happening, especially quality of materials on the market cannot be rolled out. That is the biggest that I observe, and I add on to my colleagues' comments. Thank you.
Thank you very much, Paul, adding to the responses from your colleagues about the Uganda situation. And let me just take this opportunity to congratulate the Ministry of Water and Environment. I think over the years, you've done tremendous work to significantly accelerate access to safe, sustainable water supplies in rural areas. And just to flag that the small water supply guideline that I highlighted previously that WHO has developed has included several examples from Uganda with a lot of the work that you've done to improve access to rural water in your country, from operations and maintenance to financing, etc. So now we're going to go to the last discussant. This is Adamson Sakala. So if you could turn your camera on, that would be great. From WaterAid Zambia. So we're going back to Zambia. So Adamson is a technical advisor and private sector and partnerships at WaterAid, as I mentioned, and providing technical support in those areas. So the question for you is, both WaterAid and the NGO WASH Forum have picked up on the findings and recommendations from the Stop the Rot study in Zambia, so which we heard the presentation earlier. So can you tell us about the actions and experiences that you've had so far? So over to you, Adamson.
Thank you very much. And good afternoon, good evening, and good morning. I think from the colleagues' presentations, we've seen quite a lot of work that is being done in Zambia in terms of research, documentation of the iron challenges. After the Zawafe and the report that was done by Kirsten, we picked it up as NGO WASH and the team to start following up on actions. So one of the things that we did was to engage parliamentarians. Through the current budget, the 2024, we did present the challenges because government intends to rehabilitate a number of boreholes and drill new boreholes. So they intend to drill about 1,400 boreholes and rehabilitate almost a similar number. And during the budget presentation, they requested NGO WASH to give feedback, and we did indicate that as much as we want to see these boreholes drilled and these hand pumps installed, we have a challenge of iron content, and that may not be beneficial and prudent in terms of value for money for the government to continue investing in systems that we are very much aware that they will have problems going forward. We, beyond presentation to Parliament, we have engaged through the National Development Coordinating Committee, Secretary to the Cabinet, indicating that we have this challenge and we need policy changes. We have had a number of meetings with the Ministry of Water Development and Sanitation, and we continue engaging for them to proceed and see how policy changes could be put in place. So those who have to cover the issues of standards that the colleagues have already mentioned, the issues of the quality of materials. Basically, I think the Uganda scenario where most of the materials are being imported, we too import a lot of these materials. So we need to enhance the inspection of the materials that are coming into the country. So through the Zambia Bureau of Standards, we need to ensure that we have put standards in place that can be used to monitor as these materials are entering into the country. As Javan indicated, India Mark II and AfriDev are more kind of recommended pumps under rural water supply and sanitation program. So these are government programs, and to change, we need to advocate, and we are seeing the government responding and trying to see how these things could be changed. From the NGO Watch Forum side, the members themselves, some of them have resolved not to continue using India Mark II pumps or GI pipes as they do installations of hand pumps. So a number of them, I think you heard from ECHO, there are other NGOs also, Santier and others who are doing these projects, have also decided not to proceed with GI materials when they are doing installations of India Mark II. So in short, we are doing policy advocacy, policy changes. So we are engaging. We know these processes take long to actualize results, but we are consistently engaging, and every platform we find to engage on these things, we do so. Even the coming Zawafe, this issue will be a topical issue. When we meet as NGOs, these are issues we discuss, and also every opportunity we have to engage the Ministry of Water Development, we do so that as we push this agenda, we may end up with materials that will be suitable, and we will not be spending money knowing that we will not get results out of these expenditures, and defranchised communities that are expected to benefiting from these resources. If you ask our colleagues, I think from ECHO, you find sometimes some of these boreholes, if the water is acidic, the borehole will be abandoned within 4 to 5 months of installation. So that is what we are advocating, that we should not be spending money when we know that we already have problems, and this money will not be put to good use. So basically, this is what the NGO Wash, Waterhead, and others are pushing, and that's how we are engaging government, and trust that the police work or policy engagements will result into positive results. And we are seeing these slowly happening, and we hope that soon we will have a declaration or a policy change in terms of usage of GI and India Mark II pipes. Thank you.
Thank you very much, Adamson, for highlighting what you're doing to influence government and thinking about the long-term efficiency and sustainability of these systems with using resources effectively. So now we're going to move on to the Q&A, but firstly, thank you to all the speakers and the discussants. So for the Q&A, thanks to all who posted questions, your reflections. I've seen so many messages pop up, so it's great to see the interest in this topic. So I'm going to start with 2 questions that were posted in the chat, and this is for the Zambia situation, where the question 1 is for Javan and the second question is for Annie. So I ask both of you to turn on your cameras and your mics to get ready for the questions. So this question first is for Javan. This is from Mr. Nkosi, from Clara. And she would like to know what's been done so far in terms of research to reduce the iron content in the Western province. And Annie, I'm just going to tell your question now. And the question is, how reliable are the PVC pipes in the work you've been doing? Any breakages of pipes, and also approximately what's the maximum depth that the PVC pipes are reaching? So first we'll start with Javan about the question about research to reduce iron content.
With regard to the issue of iron in some of the boreholes that Clara is talking about in Western Province, from the ministry side, what they did was to use what's called the iron removal plant. The iron removal plant is what has been recommended to be used to clean off the rust in the water. But the challenge that has come up with that unit is the issue of the cleaning of the sand. With time, the sand, which is one of the filter medium, tends to get clogged. Now, when it gets clogged, the community needs to go back and clean the sand. But many times, it is that component where the community does not go back to clean the sand so that the iron removal plant can continuously remove the iron, the rust. So the issue is we need to do more research on the social side on how the community can be encouraged to go back and clean the sand, which is in there, which they are using for cleaning up the iron from the water in the borehole. So that's what has been done. What was being done in the Western Province, the use of the iron removal plant, except the challenges on the part of the community not being able to continuously. Now, I hope I've been able to answer that question.
Thank you, Javan. I think your response was very clear and appreciated how you highlight what's been done, but also the challenges with what's been done. And when you put in place technologies, need to consider really the operations and maintenance around it. Before I hand it to you, Annie, just two points I wanted to raise. One is I can't congratulate the Ugandan government without congratulating the Zambia government. And I do that sincerely. I think Zambia has done so much to start looking at regulating rural water supply, and it's a leader in the region. And we also have a case study from Zambia in the small water supply guideline. Secondly, I want to highlight that if there is anyone from the Ministry of Water and Environment in Zambia, as well as NWASCO, the regulator, you are very welcome to share any reflections too. You could do it after Annie, or if another time during the webinar, although we're ending soon. Please post your question or ask RWSN to unmute you so you can share directly. So over to you, Annie. Annie, I can repeat the question. So the question was about how reliable are PVC pipes?
With the brand, very okay. Like I said, we are. Yes. So the person who asked about the UPVC, our recommendation would be that the UPVC are reliable because they come with stainless steel connectors, which you connect to pipes and also to the water chamber. And these are very strong. They are very tight enough. And so far, we have not experienced any breakages. Before we resorted to this particular brand, we had tested 2 other types, which were very problematic, and we lost quite a lot of investments in terms of money. So we also decided to try on the 3rd brand, which so far has proved to be working very well and is very durable. In the 5 years of our implementation, we have not had any pipe breaking apart from what the community will report as disconnection, especially with the stainless steel connecting road experience. We are yet in the problems that we can bring to a forum like this and about, but so far we are okay with the brand that we have installed in all the 1,344 hand pumps.
Many thanks, Annie, for your response. It was breaking up a little bit for me, but I think I got most of it. So thanks so much. And I see comments coming in that that many participants found the presentations and the interventions really useful. So congrats again to all the presenters and the discussants. So now I have one other question. This is, and I don't know who wants to do this. Maybe Kirsten, you want to do this, and then also if you would like to summarize, because I understand you've been responding very actively to many questions coming in the chat. So there aren't many, if any, outstanding ones. But the question is there research which shows a level of acidity according to different soil depths and when surface water infiltrates the soil?
Thank you. Thank you very much for that question, Jennifer. I mean, I think the really interesting work that Javan presented looking at soil pH and pH of the groundwater is very interesting. I think it's an area that needs more work. And although we have this threshold of 6.5 as a kind of risk, high risk of corrosion, but there's more needed to understand some of the nuances around different groundwater chemistry parameters. So more work needed, but I think for those of you who are interested in that issue, have a look at Javan's Zambia report, because that talks a lot about this kind of correlation between soil pH and groundwater pH. It's a good starting point to look at. And you wanted a bit of a summary. Is that as well, Jennifer? Did I understand you correctly?
Sure, that would be great. I thought I saw that
That's fine. Yeah, just
was posed to me to do that, to ask you.
Yeah, no, we can kind of maybe do it together. But I mean, I think what I'm hearing from this is like the importance of regulations. But having the regulations in place, as we saw from Uganda, isn't the end point. It's part of a journey, and a journey of continued learning and reflecting and improving. Also looking at some of the comments in the chat, the importance of really understanding where the source of iron is. Above a certain level, when you have high quantities of iron coming out of your hand pump, it's generally a corrosion issue, but not everybody gets that, knows that, believes that. So there's an issue there about understanding the source of the iron and really not just assuming it's coming from the ground naturally. I also think that the Zambia and the Uganda case are interesting because they show times where in projects the problem was addressed, high quality stainless steel was used or alternative materials were used, and then the country went back to using GI again, or another part of the country used GI, and lessons weren't always taken through. So what happens in the past doesn't always mean that it's going to be the same or as good in the future, and we're not learning as much from history as we should be. And also, both for Zambia and Uganda, this is a multi-stakeholder, complicated process to bring about change. It's not something that just one organization can do alone. And I'm thrilled here with the webinar, having with the group of 10 here, such a wide range of stakeholders that all have to work together in country to address this issue. So that's my, not really summary, but a kind of few salient points that I put out, and I hand back to you, Jennifer. Thank you.
Thank you, Kirsten. I think that was an excellent summary. So I'm not going to add to it, but rather I'd like to share a few reflections before we end. So one is just, again, I think this is a really useful guidance that's been developed. And I just wanted to highlight that the recommendations in this guidance note about considerations for regulations, from thinking about engaging stakeholders, thinking about the enforcement aspects, etc. those are not relevant just for corrosion. These are the same principles that should be considered in developing drinking water regulations. And in fact, we highlight basically these same principles in WHO guidance on how to develop or update regulations and standards on drinking water quality. Secondly, I wanted to highlight that the name of the session about experiences and challenges of preventing rapid corrosion of rural water supply infrastructure. Just to remind everyone that while most of the presentations discussions were about boreholes, we need to make sure that this issue is addressed in all rural water supplies, including pipe supplies. And then thirdly, just to highlight that this issue of corrosion, as we heard, this addresses wider issues in terms of water quality, in terms of also just basic access. And so just to remind everyone that we need to keep this issue in context of all the other risks in a water supply. So with that, I'd like to thank everyone, all the participants, everyone that's joined, the panelists, as well as the presenters for this really rich, informative presentation and overall session. So with that, thank you very much. And I hand it to Aline.
Good day, everyone. We'd like to thank you once again for participating. This is just the first webinar of the series. So please join us on the upcoming webinars on the 4th, 11th, 18th, and 25th of June. We'll have a second webinar on the Stop the Rot project and the webinars by the Leave No One Behind team, by Data for Action, and by Self-Supply. So thank you very much, and please do fill out our post-webinar service, and we will share all the recording and the presentations of this webinar with you. With this, I would like to close. Thank you very much. Continuation of a great day.